Hello viewers, this is Chetan Kumar HM from Stiblock Academy and Consultancy. Today I have brought an introductory session on value engineering. Let's look at the contents over here. The contents that we are going to discuss today is value of an item, value engineering process, and the need for the value engineering. Let's jump into today's session. First, let's try to understand what is meant by the value of an item. In simple terms, the value is the relationship between how much worth the item is and its actual monetary cost. Mathematically, this is expressed as the ratio of function to the cost. Now, let's try to understand this concept with a simple example. Bench. You might have seen this bench in your house or in the garden or in the parks. The primary function of the bench is to support the sitting of a person. The bench is made up of a wooden plank of around 1 inch thickness and four legs, which could either be made of wood or metal. How to increase the value of this particular product? Let me think of it. Let's provide a cushion on top of this. The cushion increases the comfort for the person who is going to sit on this. The comfort level gets increased because this provides a cushioning effect to the butt of the person who is sitting on this. We can think of another example like drinking the tea in the morning. The tea is made up of plain milk, sugar, and tea powder. If you want to increase the value of that particular tea, just add cardamom or ginger. That increases the taste of the tea and you will also feel better. Okay, let's try to understand how the value of the products could be increased by drawing a simple graph. So here the graph is of the value and sorry, the function and the cost. On the y-axis, uh, we can put the function where it can increase from 0 to some finite value, and on the x-axis there is a cost which increases from 0 to some finite value. And yeah, moving on, let's divide this graph into four quadrants. The example that I'm going to bring for this particular case is the door lock. The primary function of the door lock is to lock the door when you go outside of the house. And also, when you're inside the house, you have to shut it with a simple latch like this. Now, if you look at this door lock is made up of several components. Here we can see three brackets that are fixed to two doors, one padlock, and one more is a kind of a bracket which is having a hole and a heavy lock. Okay, so this particular uh, product comes in the last quadrant where the function is existing one and the cost is high. Let us assign a value for this x. X could be any arbitrary value. Now there comes another company which introduces another product parallelly. It is this product. So this lock is made up of just two L brackets and with a simple latch. And you can see that the most of the components are eliminated here. However, uh, the door latch is still present. This also needs the door latch to shut the door from inside. So I have put this in the bottommost quadrant because the function is existing and the cost is less as compared to the previous product. Because this main bracket with the hole is completely eliminated here by means of drilling the hole to the L brackets itself. And the value that goes for this particular example is 2x. It is just some rough calculation. Okay. Let's see another product which is introduced by another company parallelly. Oh, sorry. It is this product where the door latch is an integrated part of this, and this is not having any key, and also the lock. Here, the entry is keyless, and this is having a very heavy functions, like you just have to uh, input the security code to open the door. You need not have to carry any key along with you. Okay. So here the functions are increased, and also the cost also gets increased because of the advanced technology that is being used over here. So that's the reason I have put this under the topmost quadrant, where you can see that there is an increase of functions and the cost is also high. The value that goes for this product is 1.5 times of the X. Okay. Parallelly, there comes another product in the market where also the inside latch is integrated with this one, but you have to carry the key to lock this door. Once you shut the door, the inside latch gets locked to the door frame. Okay. And if you want to lock this door, you just have to turn this key either clockwise or anti-clockwise to make sure that these three bars are protruding out and they go inside the female part of the door frame. So this comes under the high function and the low cost, because since the this inside latch is totally removed here, and it is integrated inside the door, the function is getting increased. Okay. And there is no lock that is present, so that part is eliminated. Okay. And the handle is provided, this also adds to the function, and the value that goes for this particular product is 3x. Okay, to conclude this particular example, what we can see here is the highest value is represented by an item when it performs all the possible functions at the lowest possible overall cost without compromising the quality. Okay. Now let's move on to what the value engineering means. Value engineering is a systematic approach of reducing the cost of a component, system, or a product by simplifying the existing design without disturbing the primary and the secondary functions. Okay. Now let's see an example for the value engineering.
Hello, viewers. Good day. Let's try to understand the concept of the value engineering with a simple example. Assume that there is a requirement to design a support or a rack kind of thing to carry or to place these three utensils or the steel glasses. You might have seen in the villages or in your own house that there will be a rack kind of thing where it will be placed on two supports like this, and on top of that you can place these utensils or the steel glasses. So it's a similar kind of requirement. So this particular task is assigned to two engineers. One is Mr. A and one more is Mr. B. So Mr. A comes up with the first design. Okay. So he designs a simply supported beam with the help of this kind of material. This is an acrylic material, which is basically plastic, and uh, we have the stiffness in between. You can see here, and this is stiff enough to carry the load of these utensils. So what he does, he brings this plank and he places this on these two supports. So this forms a simply supported beam. And on the top of this beam, he places these three steel glasses. Okay, you can see that this plank is firmly placed on these two supports, and this is able to carry the weight of these three steel classes without any problem. So this is the best design that the management sees, and they approves this design. Now it's the turn of Mr. B. Okay, so they give the chance to Mr. B as well. So what Mr. B does, he mm, notices the existing design, and he thinks that there is an opportunity to do the value engineering on this particular design. Okay, so let's see what Mr. B does now. Okay, let me remove these three entrances. He sees that there could be some functional analysis that could be done on this particular design. So what is the functional analysis that he does? Okay. He thinks that why to use this costly material? Why can't we think of a low cost material on the same plank? So he comes up with a low cost material like paper. So you can see that this is a plain sheet of paper which is bent into a number of bends and which is having the same width as of this acrylic plank. Okay, so you can see that this also forms a plank, but since this is not able to close at its ends, let me close it with the help of the stapler. Okay, he places this plank on these two supports as shown here, and he tries to place the same three glasses. And you can observe here that this plank is getting deflected in the middle. Okay, so here we can clearly observe that this design is failing. Okay, this design doesn't get approved. Then the management gives another chance to Mr. B if he can comes up with optimized design with the same material. So what Mr. B does is that okay, he analyzes this design and he observes that this design is failing to carry this load. So he does some brainstorming on this particular design and comes up with another design. He uses the same sheet of paper and thinks of providing a profile like this. So this is a zigzag profile which is having a section modulus in between. Okay. Yeah. So he forms the profile like this, and let's see whether this works. Okay. So since this is not able to close by itself at the end, let me apply the same stapler as applied before. Okay. Yeah. Now this plank is ready, and he places this plank on these two supports. Okay. Now he wants to check that whether this plank carries the same load as carried by the acrylic plank. So what he does, he tries to place the same utensils on this. Yeah. So you can observe that this design is working. So uh, you can see the magic that this is not getting deflected at all in between. However, this is not so reliable as this acrylic plate or a plank. But if we can come up with a better material than the paper, so this also serves the same purpose. So what we learned from this example is that the value engineering is a systematic approach of simplifying the existing design without disturbing the function of it. Yeah, so this works, friends. So we can carry the same approach in our working environment to do the value engineering. Thank you.
Now let's move on to the value engineering process in this session. Um, I'm telling just briefly about the value engineering process because the detailed study of this process we will do it in our next session with a case study. What are the four phases in this value engineering process? The first one is the input study phase, where we get to know that particular system for which the value engineering needs to be done. We also get to know the primary and the secondary functions and collect all the inputs that are necessary to do the value engineering. Then we do the idea generation using the brainstorming process, where we come up with a lot of ideas to bring down the cost of that particular system without disturbing the function of that. And once we sort out the ideas, we do the feasibility study of those ideas in the feasibility study phase. And in the feasibility study, we just pick few ideas which can be converted to the concepts. So that exercise is done in the implementation phase, followed by the design and development. Yeah, this particular process we will study in more detail. Okay. Now, moving on to the next content here. When and why does the value engineering come into action? The first main reason is the competition, introduction of a new product. Now, if we look at this example, chair. If you look at this particular chair, so this was introduced almost 10 to 15 years before, where the price was 4,500. And there came another competitor who introduced a low cost chair at just 600 rupees. And we have all witnessed this. Okay. Of course, this is more reliable and strong compared to this particular chair. But that particular function is not necessary. So whatever the basic functions and features were needed, that was provided by this competitor. Another example is the study table or the computer or the laptop table. Now this has been much simplified and made more cheaper by just mounting it to the wall. Okay. The second main reason is the profitability. Profitability is the difference between the selling price of the item minus cost of that particular item. Cost of the item means it includes the research and development cost, manufacturing cost, overhead costs, and so on. Okay. Now, this particular concept or this particular strategy cannot be applied for the entire product. Of course, in some cases, it can be applied for the entire product, but for a portion of the product. Now, if you look at this example, so here in the left side, you have the rack and pinion example where the pinion moves this particular rack to and fro. So this includes the manufacturing of this rack, manufacturing of the pinion, and this includes a lot of greasing needs to be provided in between these two, and we have a motor and everything. This can be replaced with a simple Scotch yoke mechanism where you have a slider and a motor. So here we don't have to cut all these gears and things like that. So this also serves the same function. So in this case, the selling price was kept the same, but the cost of the item produced, it was reduced to a drastic instant. So that's the reason the profitability increased. Okay. So that's it for this particular session. And in the next session, as I mentioned, we will study more about the value engineering process with a case study in much detail. Thank you, viewers.